and few buttons. The hidden internal mechanisms involved are somehow complex and interesting. An elevator in its simplest form can be represented by the illustration shown here. An electric motor turns a pulley and a flexible rope winds or unwinds along which the elevator car rises or lowers. Similar components are assembled in an actual elevator with some modifications. It contains a braking system and a worm wheel mechanism, which will be explained momentarily. First, let's discuss about an integral component known as counterweight. The counterweight travels along vertical guide rails opposite to the direction of the elevator car. This component may appear to do nothing more than just rising and descending, but it in fact plays a very crucial role in the stability and energy efficiency of an elevator. Let's observe our previous demonstration. Here, raising the car will require very high torque. Once the car is raised, extremely powerful brakes will be required to maintain the car's position or to lower the car in a controlled manner. This is why the counterweight is introduced. The basic idea of counterweight is that if there are two equal weights attached to either end of a cable, then the system is perfectly balanced. The only job of the motor is to tip the balance one way or the other. However, in an actual elevator, the load on the car changes with the number of passengers, but the weight of the counterweight remains constant, which creates certain imbalance in the system. To minimize this imbalance, weight of counterbalance is determined by using a formula which is explained at the end of this video. Let's first discuss about the safety devices provided in elevators. A wheel is attached to the shaft of the motor with two brake arms on either side of the wheel. An electromagnetic system and a spring is used to disengage and engage the brakes. While this setup seems like a normal electromagnetic braking system, it works in an opposite way in elevators. In a typical electromagnetic braking system, the electromagnet engages the brakes and the spring disengages it by retracting the brake arms to their initial position. But in elevators, the spring engages brake when the elevator is at stop, and the electromagnet disengages the brakes as long as the car is traveling. The advantage of this system is that if there is a sudden power failure or malfunction in the electric system, the brakes will engage mechanically with the help of spring, and the elevator car comes to a safe stop without relying on electrical systems. Next to this brake sits a worm wheel mechanism. It has a very high gear reduction ratio. It can convert low torque, high speed motor input to a very high torque, low speed output. This is ideal for an elevator because the elevator car doesn't need to travel fast, but it definitely requires high torque to operate. The other advantage is that this mechanism is self-locking, which means the back drive of the worm gear by the wheel is not possible, which prevents unwanted traveling of the car. Elevators are provided with multiple steel cables to hold the carriage and the counterweight. Technically, only one of these cables can hold more load than the carriage and counterweight combined. Multiple cables are provided so that the elevator can safely operate, even if a few of them snap accidentally. But what if the worst happens and all these steel cables suddenly snap at once? If this happens, the counterweight will freefall and hit the cushioning buffers at the bottom. But the car will still not plunge to the basement. This is because a set of backup brakes are provided at the bottom of the car. These brakes are controlled by a component called overspeed governor. It is a combination of a sheave and a centrifugal braking system. A cable runs along the sheave, which is connected to a lever in the braking system. In normal conditions, the brakes follow the car and the brake lever pulls on the cable, as shown here. During this time, the centrifugal brake arms are free and rotate with the governor sheave. But if the main cables snap, the car starts falling rapidly and causes the governor sheave to spin quickly. When the sheave exceeds rated speed, the arms fly out and lock with teeth in the stationary casing. This suddenly stops the sheave and cable. As the cable stops, the brake lever is pulled upwards. This pulls the two wedged brakes and clamps them upon the guide rails. This wedged system of brakes is very powerful and prevents the car from falling. Now let's discuss how the weight of counterweight is determined. For a balanced system, the weight of counterweight should be equal to the weight of elevator car. When some load is added to the car, same weight should be added to the counterweight to balance the system. But we can't simply change the weight of counterweight for each load.
The lift is a type of vertical transport equipment that moves people or goods between floors of a building. Generally, lift is powered by electric motors that either drive cables, hoist, or pump hydraulic fluid to raise a cylindrical piston like a jack. Elevators are of two types. One, hydraulic elevator. Two, traction elevator. Hydraulic lifts are powered by electronic pumps which transmit the hydraulic fluid to the jack. The lift has a piston at its base which will push it up. On the other hand, traction lifts use ropes, sheaves, and counterweight for moving up and down. Both systems have their own set of pros and cons. Traction elevators are the most widely used elevators all over the world. Shaft. It is also known as hoistway. It is the space in which one or more elevator car moves. This space is enclosed by fireproof walls, feet, and ceiling for the travel of one or more elevators. Headroom. It is also known as overhead. It is a part of shaft between the level of the highest stop and the shaft's ceiling. Travel height. It is the length of cabin's travel between level of the lowest and the highest stop. Feet. It is a part of shaft below level of the lowest top. So if you want to calculate shaft height, it is equal to feet plus travel plus overhead. Machine room. It is a special room accessible only for the authorized persons which contains the lift drive unit, control panel and motor. It is often placed above the shaft on the very top floor. The machine room is an integral part of the elevator. With advancements in technology, the machine room is getting smaller and smaller every year, and some systems even have them installed inside the shaft. They are also known as machine roomless elevators or MRL elevators. Guide rails. They are generally made of steel and their shape is like an English letter T. They are installed vertically in a shaft to guide and direct the course of travel of an elevator car and elevator counterweights. Drive unit. Drive unit is generally placed in machine room and it is used to operate the movements, speed and torque of an elevator. If your elevator often suffers from slow starts and stops or seems to make sharp, sudden movements, the drive could be to blame. Control unit. It is also known as controller or control panel. It is placed in machine room which is generally at the top of the elevator shaft. When we press any button in a lift, the signal goes to the control unit and then it is translated through the system to tell the motor whether to move up or down. Once the elevator has reached its destination, there is a signal sent to the control room for it to either stop and let passengers board or exit it. Counterweight. It is a unit consisting of steel weights which counterbalance the weight of the car and to which the suspension ropes are attached. The weight of counterweight is equal to weight of car itself plus 40 to 50% of total weight it can carry. You can see in this picture, the car is located here. When the elevator car goes up, the counterweight goes down and vice versa, which helps in three ways. The counterweight makes it easier for the motor to raise and lower the car. Just as sitting on a seesaw, assuming the seesaw is properly balanced, you can walk up and down any number of times without ever really getting tired. Quite different from lifting someone in your arms, which tires you very quickly. Hence the motor needs to use much less force to move the car either up or down. Suppose the lift is loaded at its full capacity, which means it weighs more than the counterweight. But in this case, the motor has to lift the difference in weight between the two and supply a bit of extra force to overcome friction in the pulleys and so on. Since less force is involved, there is less strain on the cables, which makes the elevator a little bit safer. The counterweight reduces the amount of braking the elevator needs to use. Imagine if there were no counterweight.
Liwanag na yan, ha? Okay, nakita niyo yung counterweight kanina. Bumagsak. Hindi iwasan yun. Ano nga, pag umalos sa ilalim yun, yung car, ano mangyayari? Babagsak din yun, tataas yun, tapos babagsak din. Hindi iwasan yung ganun. Okay. Yung pin, ito ko nilagay. Lagi nasa ground, ano? Yung pin, nandito yung spring bumper, counterweight, saka car. Paano kung ibinitin? Nasa second floor. May ganong arkitekto, ah. Second floor, tapos ground floor. Ibinitin niya yung pit ng elevator. Dito ngayon yung spring bumper, o tatayo ko ngayon dito. Safe ba yan? Hindi. Kasi tinan nyo yung counterweight, bumagsak dito, di ba? Ito dinidesign ng 5 times ng weight nung babagsak, ng impact. Meron. Yung tao dapat hindi na dumadaan dito. No? Leon, binanggit doon sa video, pag yung car, may brake ano? May brake doon sa gilid, no? Okay. Pag ganyan nakahang, pati ang counterweight, lalagyan na rin. Standard ng Hyundai yun. Pinalalagyan ko yan. Bakit? Pag tumagos dapat yan, may counter muna. Kumapit muna sa release dapat yan. Pag nakahang ang pin, pag hindi nakahang, yun lang karang may brake. Naku, kayo lang may alam yan. No? Wow! Wow! Okay na! Yung pag-size ng traction motor, pag nag-design ko na yung wire mo, paano i-size? Sa pump, tinuro ko yung pag-size ng motor ng pump. Sa elevator, tuturuan ko din kayo mag-size ng motor ng traction. Pero may side note muna ako dito, ha? Huwag yabang muna ako. Sabi to, intermission. Facebook muna tayo. Dito muna tayo. Ayaw mo na. Ayaw! Gusto nyo ito muna.
Ang dami.
Bitin. Ito. United Center, Chicago Bulls. Ito muna, ito muna. Naka po ah. Bitin. Ito pinaka-best drive ko ito. Yan, 200. Yung pala ang pinaka-the best ko siguro. Okay. Mag-enjoy ba kayo? Mag-inspire sana kayo, ano ha? Aral, mabuti. Okay na ako. Dryer na tayo. May tanong kayo sa elevator? Wala na. Okay na ako dito. Ayaw mahugot. Thank you. Dito ay dryer. Heavy board. Nakakasitanda ako to, no? Grade 6 pa ako. 83. Nasaan na kayo ito? Nasa buhok, sir. Oh, the temperature in the dryer, number 2 na susulpi ko. Isang problem lang ano, para madali tayong buwi, ano? Woo! Ako na ipagod na rin. Temperature in the dryer is maintained constant by steam coils within the dryer. Steam coil. So, pumasok yung steam. Dryer. Mas pengen dryer. Hindi natin naman saan mo nakuha yan, no? Mali yung. The temperature of the air in the dryer is maintained constant. So temperature is constant, isothermal dryer ko. T is equal to constant. Isothermal dryer. The product enters the dryer at the rate of 1 metric ton per hour. The product, ano? Yan makikopy din. Sa Bible, di ba? The product enters, ano? MP o MM? The product enters. MP o MM? Naku ah! The product enters. Mali na kayo. Kung mo sinabing product ka na rin ano. I-enter si. Ito nag-i-exit. Oh, mali na. Ayos. Pag ka mali kayo dito, sabi ko sa inyo, mali na lahat. Per hour. Okay. The initial moisture content is 3 kilograms moisture per kilogram of rice oil. The initial moisture content F 3 kilograms moisture. Kilogram moisture. Hindi natin water vapor, ano? Per kilogram of dry solid. Per kilogram of dry solid. Ano? Percent moisture content. Dry, ano? Dry solid, wet, dry. Okay. And will be dried to a moisture content of 0.10. So kilogram of moisture, kilogram of water vapor per kilogram of dry solid. So dry siya, no? Pa-dry siya. Pareho dry. Air enters the dryer with a humidity ratio. Air enters the dryer at humidity ratio. Gawin natin to 1. Wala sinabi ng heater eh. No? So 0.016 kilogram of moisture. Kilogram of moisture is kilogram water vapor per kilogram of dry solid. Per kilogram dry air, hindi solid. Air to. Tama, moisture, no? Kilogram water vapor per kilogram dry air. And leaves with the relative humidity of, so ito 0.1, wala sinabing heater, so 0.1 tsaka 0.2 na to. So 0.2 is 100% the relative humidity. While the temperature remains constant, so T2 is ilan? 60 degrees Celsius. Equal yan sa 60 degrees Celsius. And the total pressure of the air is 101. P barometric given 101.3 kilopascal. Total amount of air. Naku, air to. Air lang naman to. Solution, so A is total amount of air. In kilogram per hour under entrance. Well, i-plug natin sa psychrometric chart muna, no? Psychrometric chart. Yung point 1, ito na. Meron yung moisture content na 0.016 kilogram of water vapor per kilogram of dry air. Ito na ito dry air. Okay, yung point na saan? Isothermal na sabi. Naku, mali. Lilihis pa natin, ano, kung ethics mo yan, lilihis mo pa, ano. Ayusin natin. Take two. Gusto ko lang umuwi, para gusto kong bumaro. 60. 2, 1. So, T1 equals T2, isothermal dryer, 60 degrees Celsius. Dry van. Ito, hindi binigay. Dapat ibigay yan sa inyo. Ito, 1983 is, open MRI check pa to. Dapat ibigay yan. So, kunin natin. Napakadali ng body exam nyo ngayon, no? Hindi nyo nasosolvein. 0.152 kilogram of water vapor per kilogram dry air. Ang nag-discard dito, saturated sa steam table ang ginamit. So, bakit steam table? Kasi ito out of bounds sa standard psychrometric chart. So, high temperature ang gagamitin mo. Para hindi ka gumamit ng high temperature psychrometric chart, P-saturation ito ang ginamit. P-saturation equals, paano ko inaibigay sa inyo? 19.94. 19.94 kilopascal. O, paano susunod yung W2? Kung hindi bibigay yan, ha? Tagalin muna natin. Hindi binigay. Yan lang ang binigay. Paano titirahin yan? Yan ang binigay yun? Yun. 0.622. Yung P-saturation na yan, yan ang partial pressure water vapor mo. 19.94 over P-barometric. Ayun na, 101.3. minus 19.94. Ilan ang lalabas? Dapat 0.15 yan. Tama ba? Oh, dalawa diskarte dyan. Either na ito ibigay sa inyo, direkta, or pahihirapan kayo, ito muna ibibigay. Kaya titirahin nyo sa ganito. Ha? So, dalawa approach. Pwede ito direkta. So, dalawa approach, ha? Ngayon, buhay ka na ba? Dito medyo matrabaho to. Ito kailangan mo. Bakit kailangan yan? Kasi ang mass of air is MF minus MP W2 minus W1. W1 ito, W2 ito, MP kailangan mo. Ngayon, magtitirin ko ba ako? Ano? Total dry naman to. Ano formula ng bone dry weight? Na bone dry weight na product ang kailangan natin. Ito nasa kaliwa, equal sa bone dry weight ng P. Anong pag dry basis? Dry o dry? Anong formula dito? Yung dry ba? Tatagal tayo. 1 plus XL ba? Pero pag exam nyo, susolvin nyo yan, ha? Minus ba? Pag i-derive nyo pa ako, no? 450 pala to. Lecture to, yun, 450 sa oras. Okay to. Kung gusto nyo i-drive ko, hindi na sa akin. Dry! Kailangan ko muna dry. Pareho dry.
Dry basic.
Ano ang FP tsaka XP? Gravy pa yata talaga ako ah. Ito lang no. Wala kayong
Sir, 1 minus. Ay, hindi, product ko.
Meron dito sa ano, MF over 1 plus percentage XF equals.
sa XP, sa drive.
MF over 1 plus.
MF over 1 plus
Ito,
percentage.
Equals
1 plus XF. Drive to ha, yung ano, yung product.
N. Percentage XF.
Ito mga plus natin. Tapos na plus yan. Okay yan. Huwag kayong maghuhula sa exam nyo dito ha. Hanapin yung try basic ko.
1 minus
Ano no?
181 minus percent. XP percent times invoice per percent.
1 minus XP. ASP. Ganito ha. Ito ko kung lalabas tayo. So ito, pwede ko na ilagay dito sa ilalim ano. 1 minus XP. Galing ko na to, no? O, equal sa NF. 1 metric ton, gawin natin kilogram. 1 metric ton, ilan? Dito na naman. 1,000 kilogram. 1,000 kilogram per hour over 1 plus 3 kilogram of water vapor per kilogram dryer. 1 plus 3 over 1 minus 0.1. Ilan ang labas nyo? Hindi na divide ng 100, no? Pinas ko na kagad. Bakit? Wala nang sinabing percentage eh. Plus mo na kagad. O ito, plus mo na rin kagad. Ilan? 225 point.
Wala sa saan.
Sakto. Tingnan ko tayo dumagi ba? 250. May mali kayo dito. Mapapalabas ko yan. Sa tayo nagkamali dyan. 250 sagot niya. Saan na tayo nagkamali? Baka ito nagkamali yan. Kaya pag-i-drive niyo pa ako, no? Baka minus to. Hindi, negative yan ako, delikado. Hindi minus yan.
Hindi mo sir parehas plus. Kasi yung
So, mga plus.
bond driving ng feed equals bond driving ng product.
Ha?
Dry kasi parehas.
O dry kasi yan sir.
Oh, dry yan.
O dry
Dapat
sir
plus
parehas.
Parehas plus.
Oo, sir.
Ito, sa calculator, ilan to?
Kung saan ka din tayo, sir?
275. Sobra naman.
Maligo yung mga...
Talaga pag-i-drive niyo pa ako talaga. Baka mali na ang reviewer, no? Kinapalabas ko to eh.
Dry. Hindi ba yung kape na? Di ba ito dry? Try pa kayo. Dry. Ay, yung W. Full.
Ginamit di ba gimana algebra siya? Ako may maintindihan to. Ito, mas malinaw yung pagkakadescribe ko nito.
problem para mag-drive.
Pareho pa rin.
Hindi mo siguro mamayin siya ano?
Ano kasi sir pwede sir ano eh. Mass ng feed times what plus percentage ng product over ano yata sir, i-multiply po yung mass ng feed sa
Ito.
ano po, moisture content po ng product. Tingnan mo na. Ito pa po yung over
Hindi ko nag-drive ba? Ilan na ako, pagod na. Ito. Kayo nga. Pareho lang naman yun eh.
Para sa mga
Ilan? Ganun ba?
Safe pa rin.
Ito 75.
Tumagal pa tayo dito, no? Ano?
Kahit sir, iba din sir sa ano, sa 1 minus XP yung baba.
Mhm.
250.
O, i-drive nyo na sa baba, ha? Ito na sa iba, 1 plus.
Parehas sir, parehas. Meron sa taas, meron sa kaya.
Parehong 1 plus 3.
Apa, 1 plus 3.
Tapos, 1 plus 3 over 1
Kasi 900. Divided by...
Dapat mo di-drive ako, no?
0.9 din sir. Bali sir, ano, dinames ko din sa 0.9 sir, yung denominator.
Multiply mo ba?
Opo.
Ito nasa ibabaw rin yan, okay yan.
Opo, kasi magkakancel sila sir, kaya 1,000 divided by 250.
Ito,
Yes sir, tapos cancel.
nakuha.
Cancel is 1 for ano. Ganun yung 250.
Ano kayo dyan, ha? Ano, drive ko ba? 1,000 over 4. Ayan, 250 yan. Kaya tingnan natin, ano, i-drive ko, sige. 250 kilogram per hour. Drive natin. Percent. Moisture, XP. Kala ko makakapri na ako dito. NP over bone dry weight equals sa moisture content ng product minus bone dry weight ng product over bone dry weight ng product equals sa moisture content ng product over bone dry weight ng product minus 1. Ako naka-plus. Bone dry weight ng product is 1 plus XP. Pagpas natin.
Kasi
MCP.
video din yan.
Ba't MCP yan? MCP pa rin, no? Bakit moisture content sa drink? Ito ang moisture content. Yan, ano? Ito ay MP. Pagod na talaga. So, MP to. MP. Ilagay natin sa ibabaw. Ito na sa ilalim. So, MP over MP over 1 plus XP. Mali na tayo. Okay, yung percent P is F over void dry weight na feed equals sa mass of feed minus void dry weight na feed over bone dry weight ng feed. Kita mo? Nagbumulto na. Percent XF equals mass ng feed bone dry weight ng feed minus 1. Pareho lang, no? Okay, so bone dry weight ng feed equal to MF 1 plus XF. Ipit natin yung dalawa ngayon. Ito ang nasa kanan kasi ito ito nasa kaliwa ito product, no? 1 plus XP equals sa MF 1 plus XF. Ito multiply doon ano. So, FP equals to MF 1 plus XP over 1 plus XF equals sa 1,000 times 1 plus 0.1 over 1 plus 3. Tignan natin kung ano lalabas dyan.
2.75.
275? 275. Mali ito ano kay Dimagi ba? Ano? Bakit 252? Mali ang isa kanya, no? Kala, ano ko na palabas ko yan? 252. Ito, dinarive natin mo, di ba? Wala akong direktor, ano? Yung kanya, algebra eh. Tapos ko mamaya sa inyo sa ano? Nag-group fiber natin, ha? 275 yan. Hindi 250, patanongin mo sa video. Okay, so 275 tayo. Saksak natin dito ngayon sa, dito na. So, MM is 1,000 minus MP, 275 kilogram. Anong moisture ito? Moisture na yan, ano? Kilogram of water vapor per hour divide. W2 is 0.152 kilogram of water vapor per kilogram of dry air minus 0.016 kilogram of water vapor per kilogram of dry air. Okay, so tanggalin natin itong water vapor. Sabay naman dalawa yan. Tanggal yun, no? Kasi ito nasa ilalim, nasa ibabaw, magiging ilalim, magkakasin yung dalawa. So, kilogram of dry air na ito. Ilan ang lalabas? Kilogram of dry air per hour. Ilan? 5,330. Mas pareho na. Ilan? 5,000? 5331 siya. O ano? Patulan nyo.
Baka palilan yung sir nang nalagay.
Baka nagkamali na siya doon. Ito talaga, dinirinig natin. Tama to. No? Okay, sunod. Pan capacity.
What?
Dapat dito ang specific volume bibigay. Kasi pan capacity, meron ka ng mass ng air. Dapat ang specific volume ibibigay dito. Yan ang ibigay. .5 cubic foot per pound. 15.5 cubic foot per pound. So, dito kung sisimula kayo, pan capacity, so B. So, dito yun, susupply mo. So, ito ang gagamitin mo, specific volume. Wala yun nasa ibabaw. Over volume, over mass. Tuntukan mo. Yung binyon na may tuntok, type element, Q yan. Ayan ang Q over M. MA. So, yan ang Q. So, specific volume times MA. Equals na 15.5 cubic foot per pound. Naku, naka-kilogram per hour, ano? 5,330.8 kilogram per hour. So, times 2.205 pounds per kilogram. So, kilogram, tanggal mo. Kilogram, pound, cubic foot per hour. Walang sense yan. Times 1 hour, 60 minutes. Tansado kaya kung gano'ng kalaki yan. Sige. Ilang Q? Meter per minute ang ginamit niya dito. Siyempre tayo. Cubic foot per minute. 225, balik lang. 2.5. 3,000.
36.56.
Ganito.
Yes, sir.
0.56 lang. Mga 3,1 yan, ano? Lagyan na. Mga 3,107. Hindi siya malaki.
Nakalagay dito sir, kailangan ay tama ko.
Kung cubic foot per cubic meter per minute. Cubic meter per minute.
Ay, sasabi dito sa cubic meter per minute.
Okay, parang convert natin sa cubic meter per minute yan. Hindi natin mapalabas natin, ano? Times 1 cubic meter is 35.31 cubic foot. 3.28 cube. Yung 35.31, o divide yung 35. Ang liit, no? O divide yung
85.93.
85. Cubic meter per minute. 85.98. Ano sabi niya? 86. 86 ano? Papatulan niyo ako. Dito. 1,331. Papatulan niyo ako. Dito na kami nagkaiba, no?
Mali ka sa ito.
Mali yun. Sige, yun na. Picture niyo na ako. Dito ako niya nagtuturo ako, no? May mali. Picture. May mali. Ang isang problem ulit tayo next meeting, ano?
Yun, no?
We have all the time in the world. Pero, basta kaya nung muna ako sandali, ano? May bago akong ano eh. May bago akong notepad. Yung pagtatype ko, naka-underline. Tulungan mo ako pasad, ha?
Okay, sir.
Sige. Nag-auto-spell. Pag Rodel, ginagawa niya Rodrigo. Napaka-parat na magpangalan, Rodrigo. Tapos, pag nagbe-messenger ako, gumagano mo. Bakit?
Ano gawa pa rin?
Ang hirap talaga pag ano, pag matanda, natuto sa computer. Viber muna kayo, bago kayo umuwi. Pero huwag niyo muna iwanan si Barsag, ha? Sabay-sabay kayo. Baka may multo dyan, no?
Kasi pag-upload na yan.
Ako hanggang susunod mo lang dito eh. Okay lang. Magpakita sa akin, aamunin ko suntukan yun. Oy, ako, tatakotin ha. Pero mo ito sa kailangan ko. Napakaganda na. Tako ka sa dali. Yung Vindicate, mas maganda yun. Ako nag-design yun eh. Yun!
Abot na yun, no? Abot na daw ang...
Kasi hindi ko makaya pag nagawa yun. Wala na siguro yun. Wala na.